What if a super Earth exists, one that's actually better than our own planet? Let's dive right into it.
In the vast expanse of the universe, Earth is often considered the pinnacle of habitability. After all, for 3.7 billion years, life has flourished here in ways we can hardly comprehend. But what if Earth isn't the best home for life? What if there are planets out there that offer even better conditions for life than our home world? Let's hunt for super habitable planets, worlds that could be more suitable for life than Earth itself.
Super interesting thought. It's giving straight up Avatar vibes. Lush jungles, glowing ecosystems, maybe even animals that don't try to kill you on sight, unlike, well, Earth. Some scientists actually think slightly bigger planets with thicker atmospheres and more stable climates could be super Earth Edens. Imagine forests that make the Amazon look like a houseplant.
Let's start by asking, what makes Earth habitable in the first place? It's the perfect combination of factors: the availability of liquid water, a stable atmosphere, and its position in the Goldilocks zone, where it's not too hot and not too cold. Earth's magnetic field shields life from harmful solar radiation, while tectonic activity recycles essential nutrients. But here's the catch. Earth isn't the only planet that could host life. And, surprisingly, it might not even be the most ideal. Recent research suggests that super habitable planets, planets with conditions even more favorable for life than Earth, could exist in the universe. These planets may have more stable environments, longer lifespans for life to evolve, and features that could foster greater biodiversity. So, what's the secret formula for a super habitable planet? Let's break it down. First, we have to talk about the star the planet orbits. While our Sun is classified as a G-type star, scientists believe that K-type stars may be more promising for super habitable planets. K-type stars are smaller, cooler, and live much longer than G-type stars, sometimes up to 70 billion years. This gives life a far greater window of time to evolve and flourish.
So Earth might just be the trial version of habitability, good but not the premium package. The idea that K-type stars could host better planets is wild. Our sun burns out in like 10 billion years, but K-types last 70 billion? That's practically lifetime warranty mode for evolution. Imagine a world where life has had 5 times longer to experiment. Dinosaurs might have had iPhones by now. It's like Earth is a decent Airbnb, but there are luxury resorts out there we haven't checked into yet.
And here's an interesting fact. K-type stars are not only more abundant, but they also emit just the right amount of ultraviolet radiation. Too much UV, like from a G-type star, can damage DNA. But K-type stars strike a balance, providing enough ultraviolet radiation for biochemical reactions, but not so much that it's harmful. Another fascinating element is the planet's size. A super habitable planet would need to be 2 to 3 times the mass of Earth. Why? A larger planet would not only have a stronger gravity, which helps retain a thicker atmosphere, but it would also sustain tectonic activity for longer. Tectonics are essential for recycling carbon and regulating climate, keeping a planet's surface stable and fertile for life. In fact, a planet with more mass means more surface area, and that's where things get really exciting. More surface area means more diverse ecosystems. Imagine a planet with vast oceans, massive continents, and rich environments where life could evolve in multiple directions, creating biodiversity far beyond anything we've seen on Earth. On a super habitable planet, life wouldn't just survive, it would thrive. Now let's shift our focus to something a bit surprising: the planet's orbit. A slightly elliptical orbit might actually make a planet more habitable. Why? Planets with elliptical orbits experience variations in distance from their star, which could lead to seasonal climate changes. These shifts in temperature and weather patterns may promote a more dynamic environment, encouraging life to adapt and evolve more robustly. Some scientists believe that these slight changes could be a driving force behind the evolution of more complex ecosystems.
Elliptical orbits as evolution's gym membership is genius. Seasonal shifts push life to adapt fast. Add in K-type stars, just right UV, plus 2 to 3 times Earth's mass for thicker air and endless tectonics, and you've got a planet with built-in climate control. More surface area equals ecosystem buffet, mega continents, endless oceans, niches everywhere. Basically Earth, but with DLC unlocked and biodiversity running on nightmare mode.
One recent study even modeled how ocean habitats might behave on planets with elliptical orbits. The results were intriguing. Marine ecosystems could not only survive, but potentially thrive in such environments, driven by improved rates of photosynthesis and the seasonal recycling of nutrients. In fact, these seasons could lead to richer, more varied environments than we find in Earth's oceans. As exciting as these theories are, the big question is, have we found any super habitable planets? The short answer is, not yet. However, in 2020, researchers identified 24 potential candidates. Of these, 2 are confirmed planets, though their status as super habitable remains under debate. One of them, Kepler 69c, is an ancient planet, about 7 billion years old, but some studies suggest its surface might be more like Venus, a planet known for its extreme, uninhabitable conditions. The other, Kepler 1126b, is also quite old, but has yet to be fully studied. The good news is that we're developing the tools to find more candidates. The James Webb Space Telescope, now in operation, is equipped to study the atmospheres of distant exoplanets in unprecedented detail. Ground-based telescopes, like the Extremely Large Telescope and the 30-meter telescope, will soon join the hunt, giving us even more ways to detect these potentially super-habitable worlds. In addition to these, several new space missions are on the horizon, including NASA's Habitable Exoplanet Observatory and the European Space Agency's Atmospheric Remote Sensing Infrared Exoplanet Large Survey. These missions will be dedicated to understanding the atmospheric conditions of distant planets, potentially revealing whether they could support life.
The wild part? Our whole alien detection playbook is basically sniff the air for farts of life. Oxygen, methane, the usual suspects. But what if life doesn't breathe like us at all? That's actually a valid question. Imagine critters chilling in methane lakes on Titan-style worlds, or weird biology humming beneath ice sheets.
But even with the most advanced technology, detecting life is another challenge. Life as we know it requires certain biosignatures. Gases like oxygen or methane, for example, present in an exoplanet's atmosphere. These indicators could signal biological processes similar to those on Earth. But scientists are also exploring the possibility of detecting unfamiliar forms of life that might not rely on the same biochemistry. Imagine life forms that thrive in environments completely different from anything we've seen on Earth, perhaps in methane lakes or under thick, icy surfaces. To search for these signatures, future space missions will deploy highly sensitive spectrometers capable of detecting even trace amounts of these gases. While identifying life outside Earth is a tall order, the discovery of even a super-habitable planet without life would be a game-changer. It would tell us that the conditions for life exist beyond our world, sparking new questions about how common or rare life truly is in the universe.
Fun fact, if Earth's oceans got even a tiny seasonal nutrient boost like those elliptical orbit models suggest, we'd probably see algae blooms on steroids, basically turning the seas into giant biological buffets. And guys, look at this quality. Animations, pacing, even the whole vibe feels a bit like Kurzgesagt. And yet, this masterpiece only has like 1,600 views? Check him out so the algorithm wakes up.
As we continue exploring, we might find that super-habitable planets offer environments even more conducive to complex life forms than Earth. With thicker atmospheres, longer-lasting tectonic activity, and varied climates driven by elliptical orbits, these planets could be brimming with biodiversity, perhaps even intelligent life waiting to be discovered. The universe is vast, and our journey to find life beyond Earth is just beginning. With every new discovery, we come closer to answering one of the most profound questions humanity has ever asked. Are we alone in the universe? Or are there other worlds out there more welcoming than our own, where life has not only emerged but thrived for billions of years? As our telescopes peer deeper into space and our spacecraft explore further than ever before, we are inching closer to finding our cosmic neighbors, or perhaps a new home for humanity. Could a super-habitable planet be the key to our future?
So here's the kicker. If super-habitable planets really exist, they wouldn't just be better homes for bacteria or fish, they could be better homes for us. Imagine humanity packing up its Wi-Fi routers and coffee addictions, moving to a world where biodiversity is overflowing, tectonics keep everything fresh, and the skies are perfectly tuned for life to flourish. It's not just a search for alien neighbors, it's a glimpse at our own possible upgrade, a cosmic reminder that Earth might be great, but maybe not the greatest. Lecture It did an amazing job with this video. The link's down in the description, check it out. And next time, let's just say we'll look at something that might surprise you. Stay nerdy.